but we're going to talk about thinking.
Now I'm going to have to think about
Yes.
it.
We're going to think about thinking because that's part of psychology, right? We're going to think about thinking, right? In the process of thought, okay? So that's part of psychology, right? Is thinking about thinking and how that works, all right? What a concept, right? So it's great, right? So the study, we're going to go through the study of the nature of thought, right? So we can fully understand how we do things we do, like learning, remembering, and behaving, right? We need to understand how we think. All right, that's part of it, right? We need to understand how we process this stuff, right? How people think. Thinking or cognition, right, is a mental activity that goes on in the brain when a person is processing information, right? That's us organizing, understanding, right? Communication, and communicating to others, right? All this we do, right? And we do this almost without even thinking. We do it kind of automatically, right? But there actually is a process in which we do this, right? There are systematic approaches in which it happens and it works through our brain, all right? Whether you realize that or not, okay? When we think, we are aware of the information as we are making decisions about it, or comparing it to other information, or using it to solve problems, right? But like I said, we do this automatically and do it so much, like it's so ingrained, okay? But what we're really doing is we're comparing things, right? When we look at things, we're comparing it. We're like, even when we're like walking, right? We're thinking, we're actually judging distances, we're comparing things, we're seeing how far things are and compared to how we're walking, if we're going to hit the table, if we're not going to hit the table, when we sit down, how close the table is, or the chair is, if it's far enough away, are we going to hit it, are we going to fall out of it? We do all this problem solving and thinking, and we're doing it almost automatically that we don't even realize it. All right. So this leads us to another thing that we do and think, which is mental imagery. Okay. So how are mental images and concepts involved in the process of thinking? And so we need to look at this. So there's short-term memories. Something we need to understand first is that short-term memories are encoded into the form of sounds and visual images. All right. Now this is something that was taught kind of in chapter 6. We didn't even go over that. I didn't think it was important because it was just one thing you needed to learn. So I skipped over that chapter. All right. I was like, yeah, we don't need this. All right. So I skipped over it. All right. So simply this: short-term memories are encoded in the form of sounds and visual memories. This forms a mental image and picture of the world. Okay. So mental images are representations that stand for objects and events. Okay, so everybody can think of, let's say, a book, right? And you have this image of a book in your head, correct? Now, if I say a car, right? Everybody automatically in their head thinks of a car, correct? Now, it's not necessarily the same car, right? Everybody thinks of a different car, probably. But if I say a red ball, I bet you almost everybody thinks of the exact same red ball. It's probably small, probably one you can put in your hand, okay? So we have these mental images, all right? But let me ask you this, guys. As fast as you can, how many windows are in your home?
7.
Well, I don't know. Yeah, me neither. What I think about this one.
It's kind of it asks this question in the book, right? And so let me ask you a question though. Did you visually walk through your house?
Yes.
I did, and you pointed at me before I could get to my living room.
But did some of you visually walk through your house?
Yeah.
Yes.
Okay, right? So you use mental imagery to figure out how many windows you had. Okay? So that's an example of it, right? Like we visually walk through our house and go, okay, all right, I walked in the door. All right, there's that one, that big window right there. All right, now if I turn down the hallway and I go into the first bedroom, there's 1, 2. Come out, go to the second bedroom, there's 1, 2. That's 5. Come out, go to the dining room, that's 6. Go into the kitchen, 7. That's 8. That's 9. There's 9 in my house. Okay, so would somebody answer that real fast? So, right. But you visualize, you get this mental image of your home, and you walk through it.
Yes.
Okay, so, all right, that's mental imagery. Okay.
If requested, I'll do that.
Okay. So researchers say it takes longer to view a mental image that is larger or covers more distance than a smaller, more compact one. In other words, so if I was going to walk from here to Duncan, okay, and I was thinking about that process to walk from here to Duncan, all right, it would take me longer to think about that mental image from walking from here to Duncan than it would, say, for me to think about that process from walking from here to Love's here in Comanche. Does that make sense?
Yeah, that makes a lot of sense because I was trying to do it.
All right. The mental imagery part of it would take me longer to process. It would take me longer to deal with because it's a longer distance. All right, that's how researchers just have proven that it takes longer time for me to deal with that, or for us to deal with that. Okay, people are even able to mentally rotate or turn images in your mind. Right, like I was talking to Brooke and a few of y'all yesterday about this because I thought it was very interesting. Right, so when we have a mental image of an object, right, and we think about it, we can actually take that object and we can rotate it in our mind and look at it from all different angles in our mind, right? But the thing is that when we do that, it takes the same amount of time to turn it in our mind as if we had it in our hand to look at it. And researchers have found that it takes the same amount of time, which I think it just shocked me to learn that. Like, I go, ooh, that's kind of neat. Because we turn it the same way and look at it the same way as we would if we had it in our hand. And this is actually something called mental rotation. It's something that they've discovered. So I just thought it was very interesting. It made me go, ooh, neat. All right, so let's talk about concepts and prototypes. All right, another aspect of thought process is called concepts. Concepts are ideas that represent a class or category of objects or events or activities. People use concepts all the time, okay? Example, all right? What if I say, think about a fruit? Everybody have an idea of a fruit? Okay.
Now I'm hungry.
Yeah. All right. But you didn't think about every type of fruit all over the world, right? There's thousands of them, right? Right? Okay, so you thought of a very specific type of fruit, okay? We use this concept, what's called a concept, to communicate with each other every day, right? Like, hey, I'm going to go eat a piece of fruit, right? We don't think about, okay, I'm going to go eat every piece of fruit, right? We just say a piece of fruit, right? So we can communicate fast and move on, right? So when I say fruit, what, I'll get to that in a minute because it's an example of something else here in a minute, okay? All right. This ability to think in terms of concepts allows us to communicate with each other, all right? Concepts defined by specific rules or features are called formal concepts, and they are super rigid, okay? For example, a square is super rigid, right? So if I say a square, right, you know that is very specific, right? So somebody define what a square is.
It has 4 sides that are even, and they are all connected, and they have a box. Yeah.
Right. Well, I mean, they're all 4 sides are even, right?
And they connect with each other.
And they have I put on here like
Two parallel lines that go into
Four-
each other.
4 equal sides and 4 90-degree angles, right? Is what I put, right? Because they have to have 4 equal sides and 4 90-degree angles, right? Because if they had just 4 equal sides, it could be a parallelogram. Right? If it just had 4 equal sides, it could be a parallelogram.
Why are we talking about math?
Because we're talking about concepts, okay? And so we're talking about formal concepts, which are very rigid, all right? Very specific rules of concepts, all right? And so if I say a square, we think of something very, very specific. Something that has 4 equal sides, which actually is defined very specifically, right? With 4 equal sides and has 4 90-degree angles, okay? Right? But because if it just had 4 equal sides, it could be a parallelogram, right? It could be shifted to one side, right? Yeah, I know, right? Like, oh, you got me, Mr. Croy. Didn't know you knew math that well. All right. So, but there's other examples of formal concepts, right? Double-blind experiments, sleep stages, and conditioned stimuli. All right. So that's just so you know what formal concepts are. All right. All right. So natural concepts, these are kind of fuzzy, and they're hard to define. These are all the types of things that are not formal concepts. They're natural concepts. They don't fit into those rigid, formal areas, right? Like we can't really define them, okay, that we talk about. All right, so let's talk about prototypes. This is the most basic example of a concept. So, like if I say, give an example of a fruit, what do you think of?
Strawberry.
Banana.
That's the first one y'all think of is banana, strawberry.
Apple.
You think apple?
Those are my favorites.
I want a strawberry.
I want a banana.
So what do you think if I ask this question, say, I don't know, in Africa?
I don't know what kind of fruit there is in Africa.
Yeah, I mean, probably in some parts of the U.S. If I say, what? Give an example of a fruit. Most people in America probably would say an apple. I would think, probably in some parts, probably say an apple. But given another part of the world, right? If I say fruit, they might say coconut, right? But we don't think in those terms, right? I might say someplace, think of a fruit, somebody might say a tomato,
That's disgusting.
right? Because a tomato is a fruit,
That's weird. It's vegetable. No, vegetables.
But if you're telling me you're going to
okay?
eat fruit,
So
yeah.
so here's the thing, right? Is this what we need to know? Prototypes differ from culture to culture, right? Prototypes develop according to the exposure a person have to the objects in that category. All right, so we have a category of fruit, right? And we have objects within that category, right? And we know that coconuts are fruit. We know that tomatoes are fruit. We know that apples are fruits, bananas, strawberries, those things, right? And y'all gave different answers when I talked about fruit, right? But your exposure to them, obviously, were significantly different, right? Maybe you were given bananas more than Miss Kirkland was, right? And so Miss Kirkland was given more apples, and so she answers apple more often than you answer strawberries or you answer bananas, right? So when you think fruit, you automatically think banana or you think strawberry. Does that make sense? Because in the category, in that prototype, when you think fruit, that's what you automatically think. Okay? Does that make sense? Y'all following me? Okay. All right. Because of all the information we take in every day, we may organize it in different forms. And these different forms are called schemes. These are mental generalizations about objects, places, events, and people. So let's give an example of a schemes. Okay, what do you think it means when I say we're going to the movie?
We're going to go watch a movie.
Okay, what is that the only thing it means?
We're going to go watch a movie.
Yeah.
Yes.
That's all it means to me.
You're going to
But-
pick me up and we're going to go to the movies.
Yeah, it means so much more than we're just going to go watch a movie, right?
Are we going to get some
Right? We're right like we're going to go travel to the movie.
We're going to get food at the movie.
Like, okay, Brooke, me and you are going to go to the movies.
You're
We're
paying.
going to
Okay? Me and you are going to go to the movies. All right? If I say that to you, right, it implies that, like, me and her are going to go to the movies. Like, we are going to go travel to the movies together.
And we're gonna watch a movie.
Right? We're going to watch the movie together. Right? We're going to get snacks or popcorn, drinks. Right? We're going to find the theater, the correct theater. Right? It implies a whole bunch of other things that we never discussed. Right? We have shortened all this conversation, all these other things down to one little phrase.
And you buy it.
And yet we have we have put all this information down to one little thing. And we do this every day.
That's pretty cool.
And we don't even realize we're doing it. Right? Can we think of any others? Anything else that we just say one little phrase and we mean a whole bunch of other stuff?
I mean, like, if you say, I'm making dinner,
Yeah.
I made dinner.
Or let's go to lunch. Like, where are we going to lunch? Sure.
Yeah. Like, right. Like, yeah. I mean, it means so much more than just this one little thing, right? So be thinking about those things, right? Maybe tomorrow, maybe you can think of a few of those, right? Think about a few of those phrases and think of some other ones, all right? That maybe we can share tomorrow, okay? All right, so here, just quick other things, all right? What are the methods people use to solve problems and make decisions? We need to answer that, all right? Yeah. So problem solving is one of those, all right? This occurs when a goal must be reached by thinking or behaving in certain ways, right? We need to know how to problem solve, right? And there's methods to doing that, right? Well, we need to be decision making, which is identifying, evaluating, and choosing, right? Choosing among several alternatives, right? That's what decision making is. It's like we need to see what it is, we need to evaluate, and then boom, we need to make a decision, right? Does anybody find it hard to make decisions?
Yes.
Yeah.
All the time.
Right. Like it's hard to sometimes, right? Even I find myself, it's hard to make decisions. Sometimes this one looks really good, and then you just doubt yourself, and you're like, oh, well, maybe that, and then anyway, yeah, it's just hard, all right? But there's some methods to decision making, and so we're going to talk about those a little bit. All right, there's the trial and error or mechanical solution. This is simply what it says it is, right? Is that try one solution after another until finding one that works, right? Trial and error, right? I tried this one. Oh, that didn't work. Oh, well, I'll try this one. That one didn't work. Okay, well, I'll try. That one didn't work. Okay, so you just keep trying until you're on your sixth marriage and finally you're happy. Right? Like, no, I'm just joking. All right?
Went a little deep there, Mr. Corey.
Just joking. All right? But it was a joke. It was a joke. All right? But, so, trial and error.
Mr. Corey, you went a little deep there.
Dark humor. It's the only way we survive. All right. Okay. So, trial and error. All right, so another method for problem solving is this, or decision making, is algorithms, all right? So algorithms are specific step-by-step procedures for solving certain types of problems. Guess what a great example of algorithms is? Math, that's right, math. Mathematical formulas.
Why are we talking about math again?
No, math, yeah. So, did you know psychology involves math, like lots of it? But we did statistics. Oh, I hated that class. Anyway, yeah, statistics. Oh, I hate statistics. All right, but here's the thing. That's an example of mathematic formulas, right? Mathematic formulas, they always result in a correct answer. Okay, that's an algorithm. Okay, good. Math aside, moving on to the next one. All right. Then we have heuristics, all right? This is a rule of thumb. It's a simple rule that is intended to apply to many situations, right? All right, so this is an educated guess based on a previous experience to narrow down the problem. That's what this is. So here's an example, all right? Okay, So if I tell you to do to learn a Word document, like Google Docs, all right, would you go out and read a manual to learn how to do Google Docs? Or would you just go to Google and type in Google search how to format Google Doc, how to format a paper in Google Docs? That one, right? Right? So because that one's the shortest, easiest one to do, right? Okay, that's what a heuristics is. Okay? It's finding the shortest path, all right, to something. Y'all following me? Right? It's not taking the
Lazy way.
yeah, more or less. Yeah, right? So it's the quickest way to get the answer. Okay? Or the fastest way. Yeah. All right, here's another way to problem solve. It's working backwards. This one you use all the time. All right, whether you realize it or not. It's working backwards from the goal, right? So if I say I need to get to loves, right? What do?
Drive
Huh?
to Loves.
If I know where Loves is at, right? I go, okay, Loves is that is off of Highway 81. So Highway 81, I need to go down whatever that road is, and then I come over to this road, right? I know where the goal's at, right? So I can work backwards to here,
I don't remember what I
right? You actually do it all the time because you put it, like you need to go somewhere, so you put it in your phone
Oh.
because you set the goal, and then it's where you're at. It does the same thing with Google Maps. Yeah. All right. So, and then there is sub goals. Here's the next one. You use this one too. You do it if you do a research paper usually. I didn't set a lot of sub goals when we did our research paper, but when you do it in Miss Miller, I think she does this a lot, where she says, okay, your introduction needs to be done by this time. Your body of paragraph needs to be done by this time, and then your conclusion needs to be done by this time, right? So sub goals is where you do smaller goals to achieve the final solution, and it makes it much closer, right? And the example, right, is writing the paper, right? So you have several sub goals, and then you reach your final destination, okay? And the last one is insight, all right? This is when a solution to a problem seems to come suddenly in the mind, right? This is that aha moment, right? Have you ever had that where you just couldn't find the solution to something, and then all of a sudden you're just like, oh my gosh, I know what needs to happen. I know what I need to do, right? And it wasn't even when you were thinking about the problem. It was when you were doing something else, right? And it's the mind simply just reorganizes the problem when we're doing something else. We don't necessarily know why that happens, but we tend to. The brain tends to work on it because it's kind of in the back of our mind, and we're doing something else, and then we have this aha moment that, oh man, I know what I need to do in this situation. And we go, aha, right? And I think we all kind of know what that feeling is, all right? Now, all these work together. All these can help us in solving problems and making decisions, okay? But these are just ways that the brain works, all right, and how we think about things, all right, and about thinking, all right? So I'm going to hand you out a worksheet. Again, tomorrow we'll move forward again, hopefully, all right? And you do have self-care out there as well, and we'll have self-care every week. It's due Wednesday. Yeah, I wanted to give you all a couple of days in. This is the only week that we do Wednesday. So, okay? All right, y'all have any questions? Concerns? Complaints?
I'm hungry.